I kept making jokes that we were gonna have 1 week of like spring and then go into summer, but no, had 1 week of spring and then went right back to winter.
Do most of them come on Zoom still?
Hmm?
Do most of your students still come on Zoom? You guys are almost done.
Yeah, not long now.
Halfway about.
Yeah, actually,
So do you go through everything in this class? Get your foundations, right?
I'd like to, but
Yeah.
that's,
Even with my 2 grade students, I quit. I quit at the right before the quadratic because I wasn't getting it wasn't helping them pass, and it was making them cry. So I stopped.
I usually, yeah, I learned the making them cry lesson really fast, so I usually try to go kind of at their pace.
Yeah, well, I had a really high class, a really good student. I'm like, so if you want to learn this is how we get. And he started crying. He got like a 17, so I'm like, I'm just not doing this. It's not worth it.
Yeah,
That is it.
yeah,
How many come in person?
usually 1 or 2. It usually builds up because a lot of people have commitments until about 6 or 6:15, so it's usually pretty slow, even on Zoom until about 6:30.
I think it's always that way.
Yeah.
I don't care what time it is, it's just that way. I need a picture of the puppy. I like the picture of the puppy in this different slide.
I fill my slideshow with memes.
Oh, that's good though. I think that's really good. I like that. Because I think then they remember it, like they'll remember the picture, the one with the words, the one with the map.
Maybe.
Hopefully. Are you still at your other job where you did the bottom thing?
Yeah.
Still like it?
Hmm?
Do you like it still?
I don't think I liked it in the first place, to be perfectly honest with you.
Oh, I just saw it when you were first starting, so at that time you still seemed kind of excited.
Well, they were gonna pay me and they were gonna pay me more than the last couple of jobs, so,
Yeah, that's always good.
come on, Pen. I know you've been sitting for a while, come on. Come on, come to life. Not on any key. Are you?
I have an extra pen if you want it.
No, these have erasable ink,
Oh, nice.
so. I always have extra ink cartridges too. Because I learned that lesson once. It'd be class 9, but it's class 7 because I missed a few.
What happens? It's really hard to be everywhere.
Right. For those of you online, I'm gonna give it a couple more minutes just in case I get some more people in. I feel like it'll happen. No emails yet. I'll often give it about 5-ish minutes.
Yes, I always think so.
Yeah.
Sometimes then I just have a conversation, just like what you doing. Oh, dubious.
We have a few less students than usual because a few of them have passed the math.
Yeah, that's good. How many are there? How many are there normally?
I mean, technically, it should be about 17. There's still several I've never seen before. But usually by the middle of class, I usually have some of the best attendance I have ever had out of this group.
Nice.
Yeah.
That's the one thing, it's like, you get half one day, half the next, and. So you have a good group.
One of them started donating plasma the other day.
Started when?
Started donating plasma the other day.
It pays, doesn't it?
Yeah. Yeah, first 2 visits are 100 each, and then it switches over to the monthly, which starts off at 40 for the first donation, then 45, 50. It goes up to 80 and then resets every month. I need to start doing that because I could use a little more.
Yeah, everybody, for sure.
I don't think they'd pass me though.
Okay.
Well, you get tested on protein, general physical fitness, you go through a physical. You get, they check your pulse, you check your blood pressure, all that. And I am not a healthy human being.
No? I gave up soda. It's water does not quench my thirst, by the way, even a little bit.
Hello, I'm also here. You guys hear me online? I can't tell if you hear me.
Yes, I do.
Okay.
Excellent, excellent, because I can't tell if I hear me. Okay, now I can tell if I hear me because I pulled up the settings and looking at the microphone, but you know, whatever. Right. All right, I guess have a slower class tonight. Whatever, I'll live. Okay. I like usually, huh?
So I'm saying,
Yeah, it usually, see, I got a couple of them, the one that started donating, and then is friends with somebody that pops up on Zoom, so they tend to keep it lively.
that's nice.
Neither one's here. So should be fun.
Play with it. Not really this way or
Fortunately, both of them are usually on time, so.
thanks.
All right, well, we got a small class tonight, and I got a lot of stuff to cover. So if you have any questions at all, of course, pop up in the chat, interrupt me, whatever you need to do. As it is today, we're going to be reviewing the last class a bit, then covering some more stuff on percentages before moving past it onto exponents and roots, which are a blast. And I did all kinds of extra stuff to make images for the actual roots last night. So that was fun. And look at those. Look at, okay, don't look at that one. That one's stupid. Look at those. Look at that. Look at what I did. Look at that. Isn't it beautiful?
Gorgeous.
Yeah, don't freak out when you see this screen, because that's like every single possible step, and it's actually more than you need to do. So don't freak out. Usually that freaks people out. Okay. So first of all, last couple of weeks I missed. Oh, welcome to the class, Ruben. See you on there. So as you know, I missed a couple of classes. And that's not fair to you guys. So a couple of points. One, check your email before class, because I absolutely am the type of person who's like, no, I'm gonna make it. I'm gonna make it until like the last couple hours, and then I just give up on life. So make sure you check your email before class in case of anything happening last minute. The main thing that I wanted to cover is whether or not we should make up lost ground, because, you know, there's a lot that, you know, that's, you know, 2 full classes. That's basically a week. So should we make up some of that stuff? Should I, shorten some of the reviews to cover more ground. Would that be useful to you guys, or do you think the reviews are that useful? I could also make small videos on certain subjects, or even full recorded class length videos that you could like pause and play and what have you. Giving you guys credit for that is going to be kind of tricky. I could figure it out. But I mean, what do you guys think would be useful for you there? Or should we just skip the whole plan idea and just charge on as usual? You guys got any thoughts? Oh man, this is gonna be so awkward for me if nobody has any thoughts. I gotta stare directly into the camera. Bueller, anybody? I love you guys too. Okay, so we have no thoughts. Nobody's willing to say that they want extra work or anything. Well, all right. I'm going to poll you guys again in the future when we have more. Okay, yeah, thank you for. Hey, somebody sent me a message. I got direct input. You can just send me a message directly that nobody else can see. I'm all for it. Short videos is one option, yeah. I like that idea. And also that was actually something I was going to bring up. That was an idea I had, because I know that we cover a lot of ground, and if there's anything you guys think we need to revisit or anything, I could just make some short videos and send them out and post them on my YouTube. I do have this guy. I want to know what I just saw on there. I do have this guy up to date. We do have, well, oh my God, no offers. Do have all of the previous classes up on here. So I do have the classes named and everything. So if you guys need to use that, feel free. So you guys are thinking maybe some shorter videos. If there's anything you need to see or need to revisit, let me know either in a direct message or an email or speak up, and I can make a couple of those if you'd like. But yeah, that's a decent option. And I do want to give you the heads up that next Thursday I may not be here. It is the most ridiculous reason that you will ever hear from a teacher in your entire life. There is a new Zelda game coming out next Friday. Next Thursday, there is a midnight release. Normally, I wouldn't care. However, there is the possibility of a collector's edition sitting there, which I will gladly throw an extra $100 at, but I might have to camp. So, if you need to, you could always, if I do cancel class that day, you could, and you really miss math, you could come over to the North Carson GameStop where I will be standing, and I could borrow the back of some receipt tape and we can do some math. It'll be fun. When I worked there, I actually did have the test. Hey, you're alive. Oh my God, there's one person in the room, everybody.
The other guy's coming.
Is he?
Yeah, I just saw him get out of his car.
Yes. People I can actually stare at until you talk. Because I know you like that. Don't make it real weird. Yeah, you missed the dorky explanation of why I possibly might not be here next Thursday. Zelda midnight release. Might have to camp. It's a good reason. I've been
Zelda from my brother.
Huh?
I never really got into Zelda with my brothers.
I highly recommend it. Highly recommend it. Hey,
brunch or something.
You came in here with pizza?
Just, you had me curious, so I brought you something.
Okay.
That pizza.
That pizza, all right. Pretzel pizza.
Yeah.
Yeah. It is in fact one of the best things I've ever had in my life. You try it, you like it?
No, I haven't. No, I actually did bring it to share with you guys.
Cool, crack it open, try
Well, I see here, right here, so here you go,
it.
Oh, and I brought my son with me.
Welcome to the party. How old are you? Do you have working plasma? What? Don't worry about it.
Go ahead, Dad, that's all you get. There.
Yeah, I'm bad.
I just had,
You just had pizza?
I just had pizza,
What kind of pizza?
frozen pizza,
Well, okay, what kind of frozen pizza?
Stouffer's French fry frozen pizzas.
Yeah,
I like those, yeah.
those are okay.
I was in a hurry.
I like the, oh, it's actually really good.
Yeah.
Right, it's like crack.
Those are like $5-6, right?
Hmm?
Little Caesars, like $5-6.
I wish there were still $6. These ones are 7 and the regular ones are 8. Not that I, memorized their menu or anything. This is how you get favoritism right here.
You don't do great.
I actually thought about grading the class, and then I realized it wouldn't count for anything.
Yeah, it doesn't. I
Well-
thought about that too, right now. it's
I thought about it,
She
it'd be
wants
like a
to
mental
build-
thing.
To build that up and
Yeah.
I like to make the math out. I'm thinking, well, how, but we don't, so I don't know.
It's the nacho cheese, that's what makes
Nacho
sense.
cheese,
Nacho cheese and pretzel crust.
is it like that dippy nacho cheese like you get in the little cheap things that taste really, are really bad for you, but taste really
I
good?
guess, I don't know what it normally comes out as if you cook it, so maybe.
Pretty sure it's not actually cheese in it too.
Yeah, it's good stuff. Yeah, so potential for a cancellation next Thursday. In case I have to camp out for the new Zelda.
That seems fair.
Well, I got on their newsletter, it says that every store should have a minimum of 4. And I know what that means. I know that means that every store is gonna randomly have 3 and that's it, and they're not gonna go over it because I worked there for too long.
So, you have to order ahead of time?
I can't, that's the thing. So if I want that addition, I better be one of the first couple of people in line. And if I want to make sure, I'm the only.
That's why you're talking about camping now.
Yeah, I already have the game on order. It just, I'm gonna be that guy. I don't care. But for those of you who have actually shown up to the class now, thank you. I'm not giving you too much crap for it, but
There's a good reason he was late, no fair.
Mhm.
yeah, all right, yeah. You get a pass real quick
I
there.
mean, if I'm gonna show up late, might as well show up.
Not wrong. Well, what I was covering, and so far we have a vote for short videos. But I've already missed 2 classes. Feel bad about it, potentially missing a 3rd. So if there's anything you guys think would help, I was considering even maybe like making an entire class just on a weekend, recording it and putting it on YouTube. And then once, I see the view counts go up and I get an email from everybody, I could give you credit for watching it. That's an option.
Yeah.
I could do short videos, like 15-ish minute long videos on different subjects and do it that way, kind of bite size wise. That's an option. Or I could just, charge on like nothing ever happened. It's entirely up to you guys. I gotta vote for short videos.
I wouldn't mind for video just because I know math is where I really need help.
Mhm.
And English already overwhelming with homework, but that would help.
Well, English is a stupid language, so I get that.
You're gonna have this English class too.
Yes.
That's what you guys, me and them already ate, I just figured I'd bring it. I was gonna be late.
Well, thank you. I don't wanna teach with my mouth full, so, leave me a slice or 2 after that. But yeah, okay, so a couple of votes for short videos. All right,
No, Robert's weird.
Yeah, I noticed that. But you know, at least we have a couple. And it'll build up in the next 10 minutes, which is one reason why I'm not super freaking out about hitting the review section really fast. Yeah, all right. I might do some videos on some subjects that I don't think we'd normally have time to get to anywhere.
So you might not be here next Thursday.
Next Thursday. Yeah. As I have here, check your email before class in case of last minute changes. That one's not gonna be a last minute. If I find out, like, I just haven't been in there, you know, friends with some of the management there, and I just haven't bugged them yet. But yeah, I'll know well before then if I have to camp out or if I can, you know, nudge somebody into favoritism, but I don't think I'm gonna be that lucky. Maybe if I pre-order like 10 games or something. Which I do normally anyway, so I don't think they care. All right. So let's hit some review stuff. I like review stuff. We love review stuff. We only just have a couple of review problems. Yeah. So percentages, percent means parts per 100. So again, the word percent per 100. Converting between percentages and decimals is the first subject we covered on that. If you're going 2 decimals, you drop the percentage symbol and move it over twice to the left, or move the decimal over twice to the left. That essentially divides it by 100. But if you can't remember, oh yeah, one way is multiply by 100, one way is divide by 100. You just remember 100% is 1, then you can usually, you know, figure your way out from there. And then if you converted a decimal to a percentage, it's the other way around. You can move the decimal point twice to the right and add the symbol. So not too bad, yeah. Converting them to fractions was also pretty simple, right? You convert it to a fraction by starting off saying, well, if it's a percentage, that means it's out of 100. So you put it over 100 and then reduce the fraction as far as you can go. Right? Good stuff. Good stuff. Let's do some. I hate that I know where both of those things are from. Left one's easy.
Right one.
Yeah, left one's How to Train Your Dragon. Right one is from a weird children's show where that was a loaf of bread. And I don't know what it was called because I've only seen weird meme videos that people have dubbed over it. So I've never actually seen it. All right. So I'm gonna write these on the notebook real quick. So you can see that we have this written a couple of different ways. Number one says take 44% and convert it to both to a decimal and a simplified fraction. So that's obviously telling us to do, you know, both of those. And then number 3 is also similarly stated there. What would be it be in a fractional form and a percentage form is just 2 different ways you might see the information presented to you, but they're both basically saying, hey, you have one of them, find the other 2 options you can find from there. Number 2 is pretty cut and dry, convert it to a percentage. There's a couple of ways to do that, so I'll show you a couple of ways to do it. Whoop. There we go. Cool. So I just kind of have it written out really quickly as notes. 44%, I have it pointing to a decimal and fraction. Just an easy way for me to remember. So it's just, it can be very useful to, you know, make little quick notes to kind of keep you straight in what you're aiming for here. So let's say that we wanted to find both of these. We want the decimal. We could find that one really quick first and then find the fraction. So 44%, if we're converting it to a decimal, remember you find where the decimal point would be right now, should be after the number, and we're going to move it 2 to the left. And then you can't just have that period kind of sitting out in space. So we put a 0 in front of it. Now, granted, sometimes in the middle of, you know, doing steps or what have you, you might not have that 0 there. But if it's your final answer, you're done with it and everything, I do recommend making sure you don't have any decimals floating in space. That would be bad. Don't make things float in space. Okay. Now we got to convert it to a fraction, right? So we're converting it to a fraction. Remember, it's a percentage, so it's out of 100. Put it over 100, yeah. And then you can reduce it. Now, you might not be able to see everything it can reduce by right away. So you could just be kind of cheap about it and say, oh, I can chop both of those in half and then see if you can chop it in half again. As it is, looking at these, I could look at 44 and say, well, what would go into that? 4 and 11, right? You know, you could chop up the 4 further if you need to, but I can look at 100 and say, oh, 4 goes into that, right? So if 4 goes into each of these, how many times does it go into 44? Huh? What? 11? Yeah. How many times does it go to 100? You don't know?
78.
That is horribly wrong. Why?
I just thought of 7.
Okay. Okay, so you have a dollar, and you chop that dollar into 4.
Okay. Oh,
How many quarters in a dollar?
I was
So-
trying to
So 4 into 100 would be. So you said there's 4 quarters in a dollar.
myself too.
I'm so confused.
So 4 quarters in a dollar,
Yeah, but each quarter costs,
45 cents.
yeah.
So if I have 100 cents and I divide it by 4, if I do reverse, if I do a fat family. So 4 times 25 is 100,
It's almost there.
and 100 divided by 4 has to be.
Oh,
So,
how does that make sense?
thank you.
See, I like to let them suffer a little bit until it clicks. That's my favorite part of my day.
Well, he's got pizza, his stomach's still something.
Yeah, so 11 over 25. Cool.
How did you get the 25?
You get the 25 by saying how many times does 4 go into 100?
Yep.
Now that one, think about 100. 100 is 100 pennies. You think about it that way. There's 4 quarters in a dollar. Each quarter is worth 25 cents. So you know that that 25 cents would fit into a dollar 4 times. So that's where we can quickly say, oh yeah, it's 25 based on some of the things we already know.
Oh, okay, okay. Okay, thank you.
Now, one interesting way to do that, it's a little funky, but it kind of touches on what we, you know, covered with the, I know you don't want me to say it again, but greatest common factor, least common multiple, all that stuff. I know it was your favorite thing, guys.
Oh, yeah.
But we could actually be really cheap about this and find the prime factorizations of everything. Because if you think about it. If you think about it, each of these numbers are these factors, right? So right now I have on top with that 44, I have 2 times 2 times 11. And on the bottom, I have 100. So I have 2 times 2 times 5 times 5. Well, you can cancel out those factors right there too. You can do it that way. And you can get that 11 over 25. You could look at it that way. You could do the prime factorization, keep in mind that one is on top of the other and cross them out that way. That's another way to look at it. And then whatever you have left is whatever's left there. You know, a lot of different ways you can approach this. So if you don't know how to reduce it, you can always do that. Or like I said, you could start off with 44 over 100, say, I don't know what goes into that, but I know they're both even, chop them both in half. And say, well, I don't know what goes into that, but I know they're both even, chop them both in half. And that's another way to approach the fact that you just took out that 2 and that 2. So there's a lot of different ways you can run at this, you know. You can do the usual, you could factor things down and cancel out factors. You could just stumble your way through it as a bunch of different steps. Doesn't make it wrong, just means that it's a different way to look at it. So, options.
78.
Huh?
78.
Yeah, not 78. Although now I need to put 78 into one of the problems at some point. Could always make it worse and to be like, hey, what's half of 78? No, think about it. Think about it. Half of 78. What even number is 78 close to? 80, right?
80,
What's half of 80?
40,
Okay, so if I had to
38.
close. What's the difference between 78 and 80? 2, right? Okay, what's half of that 2? 1. Okay, so if I'm going from half of 80 being 40, and I have to do half of 78, I could chop in half that difference there and only come off from that 40 from that difference.
Yeah.
So I could say, okay, 40 minus that half of that difference is 1. 40 minus 1 is 39. It's an awkward way to look at it, but yeah. Get something to compare it to and then kind of work your way out from it.
I have a question. Can you guys hear me?
One, yeah, I can hear you too. What kind of chips you eating?
No, I'm opening an Amazon package, but I'm just
would've got
checking
that wrong.
because yesterday my Zoom was like not working out of nowhere. Like they could hear me, but I couldn't hear you guys. But I'm just making sure.
Yeah, that's fair. Worst case scenario, you ever run into that again, just take whatever your device you're working with and hit restart.
Okay.
That usually solves a lot of problems.
Okay.
Not solved my problems with my Steam Deck yesterday, and I hated life for about 8 hours and ended up reformatting the whole freaking thing. That's how I spent an entire day off, was fighting with a piece of electronics. You ever go looking for something, like you have to do one thing and then you're like, I need this adapter, and then I have to go find that adapter and I can't find that and I tear everything apart. And you ever just go off on a tangent from a tangent from a tangent and end up doing some weird wacky thing? Yeah, like, a couple hours later. Yeah, I couldn't find an adapter for about 3 hours. Then I was like, all right, fine, I give up. I'm just gonna do what I knew was gonna work in the first place. Less than 5 minutes later, I had it working. Several hours. Okay. 14 out of 25, and we're converting that to a percentage. Now, there are many ways to do this. The easiest kind of cut and dry way of doing it would be to, if you divide these two numbers here, you would get a decimal form of it, right? 14/25 is the same as 14 divided by 25. Well, that's never happened before. All right,
I'm say it that time.
I think that was,
Like a button.
I think that was motion control, but we've never,
There too.
yeah, because those are motion control. If I walk out there, it'll turn on. Isn't there usually a class going on over there?
Yeah, they're usually pretty loud.
And they're loud as hell, yeah. Huh, all right, whatever. Lots of weirdness. I don't care. We're alive. Anyway, we have 0.56. 0.56. Well, now we need to go from a decimal to a fraction, right? All right. Well, we already know how to do that. Or from a decimal to a percentage. I started with a fraction. We already know how to do that, right? We just take that decimal point, move it over 2. So you're essentially multiplying it by 100. So we get 56, slap that percentage symbol on there. That's one way to do it. And every once in a while you get lucky with numbers and you can actually get there a different way by noticing that, hey, I know that 25 goes into 100 4 times. We definitely know that one now. So what you could do is you could multiply it by 4/4 to get 56 out of 100. And then we know that that's basically the definition of percentage, right? So that is 56%. That's not always going to work because sometimes you're not going to have something that goes evenly into 100. I'm going to say most of the time you're not going to have anything that goes evenly into 100, but it's an option. Okay. Then number 3 needed 0.54 as a fraction and a percentage. Well, the percentage is the quicker one, right? So let's get that one out of the way. We just did that from here. All we have to do to get to a percentage is move that decimal point over twice. We get 54. I started writing 55. I don't know. Stupid brain. Them neurons are misfiring again. Move that over 2, slap a percentage symbol on it, and we already got our percentage. Not bad there, but we also need a fraction. So as usual, we can take that and put it out of 100. Similarly, we could have started off that way and said, hey, what place is this in? This is in the hundreds place, and still said we'd have 54 out of 100. That's an option too. And then you can reduce it. I don't know what goes into those, but they're both even. So 27 is a bunch of 3's multiplied together, right? And the downside of a bunch of 3's multiplied together is 3 doesn't go into 50, which means that's as simple as we can get it. Not too bad, yeah? Okay, any questions on just the quick conversions there? Sure. We also did some problems on working with the percentages. So you could use the percentages to give us exact values when we're comparing numbers. So finding 18% of 27 is easy. You just convert the 18 to a decimal. So 0.18 and multiply it onto that 27. Whatever you get from there is going to be, you know, the 18% of that 27. So if you look at how that's set up, you have a percentage multiplied onto a whole amount, and it always equals out to a partial amount. So based on that idea, if you remember what I was saying, if you have any formula and you have all the things needed in that formula except for one, you can find that one. We have three things here happening here, right? We have a percentage, we have a full number, and we have part of that. If you have two of those at all, you can find the third. I saw that and I loved it. My favorite thing when I was tutoring all the regular classes was I got to point out that people were getting spoon-fed the definition of a derivative from calculus since 126. Just like one step at a time. In fact, I mean, nobody was ever going to remember that they were getting spoon-fed for that when you see part of it every 6 months, but when I was tutoring it, I was like, oh, hey, I didn't even notice this. Okay. And notice, oh God, we need to pay attention because look, there's some that say that you're going to have to do them alone. Oh my God, how terrible. I bet I could eat a slice of pizza in 6 minutes. All right.
Easy.
That first one, you can just multiply it, the one that we have to do on by ourselves.
On this first one?
Yeah.
Not quite, not quite. You know what? I combined the wrong two slides. You figuring that out? Ouch.
I do that all the time.
Ah. All right. Those are wrong problems. Don't judge me.
Or judging, it's okay.
Okay, whatever.
Just in silence.
Just quietly.
When did I cover percentages? Or did I cover percentages in the fall? I don't remember. Okay.
You can just make some up.
You know, that would have made sense. I don't like making sense.
Sorry. I'll try not to do it again. No more sense.
Here's what I'm gonna do. All right. Let's make that horrible. There we go. Whatever.
He's very good at that.
Whatever. Yeah, you don't want me to make up problems.
Sorry, guys.
Usually people figure that out really quick, but
You can give them one easy one.
well, see, I'm gonna keep those ones down there.
Oh, okay.
Those ones they're doing alone. I'm gonna work out the ugly ones.
Okay.
The ugly ones are
Oh,
gonna
make
be.
them as ugly as you want then.
Yeah, let's say, yeah, whatever, that'll do. Ah, there we
Calculators,
go.
right?
Huh?
You got your calculators, right?
Yeah, oh, yeah.
I don't like that number. There we go. I still don't like that number. Let's put a 3 in there. All right, I like it more.
Carried away this time.
Uh-huh.
There we go. I like that one.
Okay.
Isn't that beautiful? Aren't you guys excited?
I don't have to.
Huh? Yeah. I have such an incredible temptation to make that like an 8-digit number or something. Cause it's just as easy if it's 2 digits versus 8 digits, cause you're gonna use the calculator.
Yeah.
Hey guys, Link is gonna guide you. It's gonna be okay. It's gonna be okay. I might be a nerd. Okay.
So you ready to lock yourself in your room?
What do you think I've been doing the last 2 days anyway? This is day 2 of being off. I don't think, did I leave the room since I got home? No. No, since I got home Friday, this is the first time I've left the room. No way.
I saw you Sunday.
Yeah, it was Sunday. Never mind. It wasn't that long of a weekend. Yeah, since then. Although I did have to run some errands and everything that night, but whatever, since then. All right, so what percentage is 543 of 3,254? I don't care how ugly these numbers are. It doesn't matter to me what they are. It doesn't matter to you what they are, because every single one of these is gonna follow that same sort of idea that we had in that example on the review page, right? Every single time we had a percentage of something is whatever the partial of it is, right? Every single time, no exceptions. So if I'm looking for the percentage, what percentage is 543 of 3,254? Well, we're gonna kind of set it up like this, right? We need to know what percentage is being multiplied onto the big number that gives us the small number. Now, I don't know what that is, so we're gonna go the algebra route of it. You just pick it up, pick a variable. I don't care what I pick. Like I said before, it doesn't matter. You could do X, you could do Y, you could do P for percentage, you could draw a small picture of a pineapple. It does not matter. It is a thing representing, I don't know. So I don't know. Times 3,254 is equal to 543. Okay. Now, right now, we have to get this thing alone. And the only way to do that is to undo essentially whatever's happening to it. Right now, it has this number multiplying onto it. So to get that alone, we're going to divide both sides by that. So we get P is that over that. And that will work every single time. If you are looking to just find what percentage some number is of some other number, you can divide the partial over the original amount, and that will work out every time. Now, this will give you a decimal form of the answer, 543 over 3,254. We get this big ugly thing, right? Like I said before, I usually like to take a couple of decimals out further than I normally care to. Because, well, I mean, usually it just depends on what we're rounding to. And I didn't give any instructions on what we're rounding to, so. Say we're rounding to the first, no, to the closest whole percentage. All right. Yeah, so we'd have to convert it to a percentage first by moving the decimal over.
That was, first.
Yeah, and see that decimal still stays there in that percentage.
Yeah.
At this point, this is where you'd want to round. I don't recommend rounding until your last step. So if we're rounding to the nearest whole number, we look at the next digit over, it's a 6, that's greater than 5. So that means that this is gonna go up, so we have 17%.
So the 8 on the divider.
Yeah, so whenever you're whatever you're rounding to, all that matters is that digit and the digit following it. Now, if I had said that I wanted to round to the nearest 1/10 of a percentage.
Yeah.
Then I would be looking here and here. If I looked at the closest 100th, I'd be looking here and here. If I was looking at the closest thousandth, then I'd be looking at my calculator over here and say that I already did. But you know. It's always that digit and the digit after it. Now, for the record, I don't like rounding that to the nearest percentage. I totally like this. Totally like the one with some more, because that's more accurate, right? If I found 17% of this number, it's not gonna be 543. Okay. Any questions on that one? Gonna take that as a no. All right. All right, so number 2, 24 is 87% of what? Wake up. You can do it. You can do it. I believe in you. You have the power within you. Should see me at work. I'm walking around yawning and I'm like swinging a needle around. People are like, oh God, what's about to happen to me?
Well, that's the whole reason why I went. See that was true and it is.
Right?
It is.
I am not paying, like, I figure that too much professionalism makes people nervous. You come around with a clipboard and you're acting all serious and, you know, being, that just freaks you out, man. I don't want people to freak out. Oh my God. All right, so 24 is 87% of what? Well, following that same idea, we know that 87% of something is gonna end up being that 24, right? So first of all, we'd have to convert that 87 to a decimal. Now, we don't have to really go out of our way to do that every time. We don't need to write it out and say, oh, this moves over twice and it equals that. If you look at this and say, oh, it's 87%, I know that that decimal is going to move over twice and be a 0.87. That's all you really have to stress. You don't have to write out the whole, you know, steps of working that out every single time. So we have 0.87 and it's 87% of what is that 24. So it's going to multiply onto, I don't know. What variable do we want to use? I don't know. I called it what? So how about a W? That'll do. Couldn't care less. And that is going to end up being 24. Okay. So exactly like the last one, you're trying to get that thing alone. It's being multiplied by this number. So we're going to divide it off. See, it always fills out. Okay. We're going to divide that off. So our W would equal, I don't know, whatever that is. Something bigger than that. 24 divided by 0.87. That big ugly thing. And remember, that was our percentage, so we don't have to worry about rounding, like moving the decimal and then rounding. This is just a solid number, right? So we're just going to take that to however many decimals we feel like. Like I've said before, a good rule of thumb is 3 digits. I always kind of like that way. Three's nice and neat and usually covers all the bases you need to use if you have to use it for anything. It's just been instilled upon us. But that's it. Does that make sense? Kinda, yeah, yeah. Like that your nod turned into like cracking the neck. I was like, what's happening to his head? It just started rotating. Yeah, there you go. You never go full bobblehead. All right. So what is 27.03% of 15,674? Same idea, right? We have the percentage, we have the original amount, and we're looking for the smaller amount, right? So we know that it's going to be 27.03%. Well, how do you convert that thing to a decimal? Because it already has a decimal, right? Anything special? No. It doesn't matter how complicated your numbers look or how simple they look. The same rule is going to apply no matter what. Here, we just moved the decimal over twice. So it doesn't matter if this is slightly uglier. We're still just going to move the decimal over twice. Does not matter what the numbers are. The rules are going to stick around no matter what. So we have 0.2703. And we're going to find that percentage of that thing. Now, I could set it equal to some variable and work it out that way, but everything's on one side. We don't really need to put a variable or anything there, right? We know what we're solving for. All right, there's a thing. Yeah. It's 27% of 15,000. So if you think about it, that's kind of close to 30% of 15,000. So it's going to be close to like a third of that, right? So we knew it'd be in that ballpark. And again, I'm going to round it to 3 decimal places. Since the third one is a 2 and the next digit's a 2, then it's just going to stay. All right. Does that make sense? Do we have questions? I'm going to make you do a bunch of these right now. If you got questions, do them.
Yeah.
Oh, that woke you up for real quick. I'm sorry, what was that? Online? Somebody said something, I didn't hear. Maybe, maybe not. Maybe we're opening more Amazon packages, I don't know. I'm waiting for a package from China, it hasn't shown up yet, I'm annoyed.
You order on Wednesday.
Close, AliExpress. But it has a tracking number, and the tracking number says it's in Carson, but the tracking number has said it's been in Carson since the 27th.
Oh.
So we're waiting. I bought a capture card for that new Zelda game. So I could you know, play it with the long distance girlfriend. And I am 100% not going to spend $150 on a capture card. So we're going to try one of those jank $20 Chinese ones.
Whatever gets it done.
I figure I can make it work. The hardware's there, software is not there yet. There's apparently no software. I'm going to make it happen. So look at that slide. Isn't that a beautiful slide? That slide says, do those last 3 numbers alone and round to the nearest 2 decimal places. Because I actually had the forethought of writing that down for once on the rounding. So give it a shot, guys. If you have questions, as usual, ask them. If you're horribly stuck, I believe in you. I'm going to try to shut up. Very bad at it. I know how to do that. Huh?
What'd you say?
I said, I know how to shut up. He says,
Oh, there you go.
yeah. I should break out the Jeopardy song.
I think like classical music is supposed to help people think. I don't know if it works or not. But it's annoying stuff.
If I tried to do that right now, it'd be video game music.
I wonder. So you guys are to 8:30. Okay, stay till about 7:15.
That's fair.
So we're all leaving at 7:15.
No,
Sorry.
no, you're stuck with me.
Would I be rounding? Like, for example, on one, would I be rounding it up?
We all know I don't know what these answers are. I don't make a answer key. I figure it up as I go along.
That's smart because then if they say stuff, you don't know if it's right or wrong, so it doesn't give it away.
Right?
On your face. No.
So let's see. That would be one where you'd want to move the decimal over first and then round after that. And after that, the digit is a 5. It would round up, yes. Mhm, mhm, mhm. I don't know if this counter is sanitary, but I don't care. Little Caesar's pizza. I hope it's not sanitary.
Yeah. Too much sanitary is not good for you. It just decreases your immunity anyway.
When I made it to this college, there used to be a burger place in the downstairs over here in Aspen.
Oh,
You remember that at all?
yeah, I know.
They used to fight with faculty all the time and they had all kinds of health code violations. They would make. They'd prepare fish and beef in the same platter.
Uh-oh.
Health food code violations everywhere. That was the tastiest burger I've ever had in my entire life.
Yeah, that's bad. That's I'm allergic to fish. So for me, like, really bad.
Every once in a while, I figure out I'm allergic to something. I don't know what. But I got new hot sauce. And it makes the roof of my mouth itch like crazy. I'm like, that's
You
not good.
still like it?
No Valentina's.
Mm.
Could take it or leave it.
So do you have any ideas about like math or how to make it like consistent through classes or anything like you want? Different, same? Like any input you want, like,
What do you mean?
well. it's
In
like-
what
They
context?
kind of want, my understanding is like they want like a consistent. don't really understand it.
Like a consistent
Almost a
curriculum?
not a curriculum, because that could change. It's consistent standards, and
Mhm.
like, framework for implementation, which not necessarily how to, but like within this, we do this.
Methodology.
Yeah, basically, yeah. That's what we're building.
Haven't seen any of that.
Haven't done it yet.
Yeah.
That's why, is there anything you'd like to see, think of, add, take out?
Well, you can see if there's multiple ways to do something. I like to cover my bases.
Yeah, that's definite. Rephrasing, almost like.
Sometimes it clicks one way and not the other.
But I meant in terms of like a program throughout the different math classes. And that
Yeah,
was- everybody was still like, you have your own style and like doing that. Anything that you need to help you or you're good.
have you seen my crazy spreadsheet? Okay.
Is it too crazy?
Hmm?
Is it way crazy?
Apologies if anyone is currently staring at this slideshow because I need this for a second.
Is it like your standards or
Actually,
your curriculum layout?
yeah, that.
I forget what they call it. They had the words, what they use.
Try to. Please go away, controls. I need the top of the screen. Is this working as well as?
You can send it to me later if you want. Let me
Right.
look at it. How's that? Curriculum review project?
Yeah, that thing. So I started off with the spreadsheet that Kevin had made.
Yeah, I saw his. And everybody's orders are almost identical, like the way that people think it should be taught. All three matched. Yours matched, mine matched his.
Yeah.
So that was consistent.
There was a little difference with mine, but I decided just like, well, if everybody's doing it that way, I'm gonna. You know,
Yours was only minorly different.
yeah, well, I was also crazy and I was trying to fit
Everything into. small.
algebra earlier.
Yeah,
So what
so
I
you moved
did,
algebra after geometry.
because I've written so much for this class through the
Mhm.
slides. What I ended up doing was I just filled up a column of
Math.
the subjects that I covered.
And did you match it to questions on the high set? Because that's what I was doing.
I wasn't matching it to anything on the high set because as far as I was aware, we had to match it to the CASAS more.
You do, but also to the classes and then like materials. So in the mine will have one of the materials column. So page this in essential ed, page this question on the test.
Yeah, so I don't,
That's okay, because that's kind of what I'm asking.
yeah, I don't know what, I don't know what test. I don't have
I
access
just
to
use like sample tests, like,
sample tests.
yeah, so I'll pick like test 7 from this blank year, and then this is question blank, or
That's fair. That's
yeah,
fair.
it just, that's more for me, because the hustle class is so fast,
Yeah.
4 days.
What I have is I have this class trying to follow the level A and B because that's where most people were in this one.
Yeah,
I don't remember.
and then
where that's-
he's CD too, right, Kevin?
I don't
His
know.
last technical.
I don't know what he's doing right now. I think he was doing roughly the same thing that I was right now and just doing the AB.
Isn't he? Yeah, okay. He was one up, but that might not be true.
But yeah, I just use my own material.
That's okay. And so yours is not matched to essential ed, you create your own, right?
I started off originally with the essential ed.
Books, yeah.
Yeah, not even the books, just the outline from the website.
Mhm.
And I structured my first class around that and I've just kind of tweaked it ever since.
Mhm.
So that's why mine is matched
So do you
up
match
so
to the
well.
green high step book?
I just kept that with from Kevin's.
Okay,
I didn't do any of that
okay, so
myself.
he's matching it to the quit test, but he
Yeah.
doesn't say which test. Got
Well, mathematics for the HISA test is the name of the green book.
it. Okay,
Yeah,
so he's matching to the green book.
yeah. He actually. He was matching it to all of the materials. So he was using core skills in mathematics,
Right.
central math, all that stuff.
And do you have it up on the shared drive, the one that you combined his to yours or whatever?
No,
Can you
well,
email it to me?
Yeah.
Yeah, and then
Um,
I can compare it to what we have so far.
yeah, cause I've. Done a fair amount, my eventual.
Yeah, I can tell you have a lot of, like, so I rewrote essential ed for mine.
Mhm.
And then. Yeah, that works.
Yeah, I just have. Like every time I. Teach the class, I tweak it a little bit more, a little bit more, and a little bit more, and right now I'm working off of the slides I used for fall.
Mhm.
And I'm almost following that to a T.
So
Not
every time
actually.
it always gets better, that's just the way it goes. Mhm.
But.
I like it. Yeah, if you could just email me, that would help a ton.
I'll send you that, yeah, because in that spreadsheet that I have, it also has links to my fall folders.
Okay.
So that's all the materials I was starting off with at this class.
And do you and Kevin share?
Hmm?
Do you and Kevin share materials?
Not really, no, we haven't talked about anything as far as I know. He's doing one more of a workshop,
Yeah, yes.
but we haven't really collaborated on anything.
Yeah, well, I wasn't anything clever, I was just thinking like. A
Yeah.
resource bin kind of thing.
That would make sense. I have plagiarized an insane amount from the internet.
Yeah, put it over it. Yeah, that's all, that would
Oh,
be
yeah.
like just a huge bin, but labeled and consistent either by content, standard, or person, it wouldn't matter. Level. I think
Just
that
got
would
an
be
email about a student being absent.
fine. That's okay, but I think like a resource bin might be really helpful.
What I'd like to do is I'd like to rewrite everything and make my own charts and graphs and everything from what I've copied from elsewhere and just make my own.
That's pretty time consuming.
My goal is to throw it all into a desktop publishing software and make a textbook out of it, and then
Nice, that's a great idea.
just release it to the public domain.
You know, you could even, with what you have, like,
Mm-hmm.
take some of them, like especially your old ones, maybe put them up on teachers, pay teachers. You don't think so?
No, because I plagiarized stuff, so it's.
Oh, okay, yeah, then no, don't.
It
do
is,
that.
it is absolutely not all my original work or my original question, so
Okay,
I
yeah,
need
that
to.
would be illegal then.
Yes, that would be very illegal.
We don't want to go to prison, right?
I mean, I do plenty of illegal stuff in terms of like piracy, but I don't, it's distribution where they get you.
Yeah, I gotcha,
Yeah,
but you can still share it with us because we wouldn't tell.
that's fair, that's fair.
That's a plan.
That's an interesting question. Could I email you what she asked? So are you kind of looking for like, and this is directed to Alexis, or anybody who feels like chipping in, are you basically asking for like an outline of everything you need to know? Is that kind of,
Yeah, that wouldn't be
Yeah.
bad.
why is
Almost like a
it?
syllabus.
Yeah,
That's what we could, that's
yeah.
what we could create, and then when we build it, we could have to send it out.
Mhm. The problem with that is that everything we're
needs
covering in
content.
this class might cover half of it.
That'd be okay though, because you could.
Yeah.
We can build that we can't send it out yet, because we can't send out all the detail that you have up there, I don't think,
Some of it.
some of it.
The CASAS stuff is freely available on the CASAS website. Which I definitely know, you should see what I have. I went on their website and I downloaded every single PDF I could find.
That's okay, as long as you're not selling them.
No, it's also like, it doesn't actually have math in them.
But
I
I
don't
wonder
think.
if we could build a simple one that every class could get all the time to know where they were going and where they are now. Like, this is you, kind of like a map.
Yeah, and that's why I called this a map. It's really like, this guy is basically the goals.
And you have it colored by level, right? Or no, the blue, green, yellow.
Kevin sure did.
Alright, you can take your credit, he's not here.
I'm not taking anybody's credit, whether they're here or not.
Alright,
Credit to where credit
That's
is
him.
due. No, my contribution is this giant column of everything I've done for the class, and I have.
okay,
I mean, I think there's a couple of things that need to be worked on past that, but I have written
Okay.
something for every single
so this
subject.
isn't set up by aid level, so yeah,
By what?
aid level is
No,
aid level.
no, yeah,
Oh,
it's
okay,
just straight from the.
the project thing. Curriculum
Yeah,
project.
it was off, was it math? No, wasn't that,
Mhm.
wasn't that. That,
Gotcha,
the accelerator, yeah, it's just straight,
straight out there,
yeah. Yeah, the AB stuff, CD stuff,
okay,
so I'm not even gonna lie, I have no idea about any of the AB levels, I have no
Okay.
idea. Not in the slightest, I have no idea,
that's okay, that'll be my contribution then,
yeah, I have nothing but math in my brain.
that's perfect.
And I also don't even have half of the words that describe math in my brain.
Yeah, just email me that when you get a chance.
I have to write that down, because otherwise I won't.
Yeah.
That'll work.
Thanks.
Okay, so now that you know, you've had
Plenty of time.
an insane amount of time to do 3 problems. I apologize, everyone, for the derailing. If you want to
My
review the derailing, there will be a recording of the derailing on YouTube available later.
Blame me.
Yeah, you're blamed.
Okay.
They're used to me rambling anyway. I'm very easy to derail.
I was about to say that, so.
I've actually heard that. That is the one thing I have heard.
Very, very easy to derail. In fact, usually during these times, I like to figure out what the answers are, so I have something to compare. And I did not have the option of doing so,
Well,
so.
maybe in class we compare with online. Then you don't have to do it at all.
I hate the idea of me not doing it at all. Cool, so.
I was gonna make, because my daughter had been playing, Mario was in too, the party,
Mario Party,
yeah, that
I
one.
love Mario.
And then I get the time, I'm like, oh, shoot, I gotta go.
I can't say I have a whole lot of experience with Mario Party because I am a hermit.
My kids
Um,
love that game.
huh?
My kids love that game. Mario Party, Mario Kart, that's what they love.
Depends on the Mario Party. Some of the older Mario parties are great, some of the newer ones are too chance based.
I like to play with my 4-year-old, I don't like playing it with my 13-year-old.
There was,
I know Mario.
You know, my kids are older than you. So probably.
it's like it's a Mario themed party game where there's a ton of different mini games and it's like set up like a board game, so everybody's playing at the same time.
I go straight to the.
Oh, wait.
I don't like the board game,
No,
Okay, no, wait, I'm done.
okay.
but that's the whole reason I got it, because of the mini games. I don't like the board game of it.
Hmm. Yeah, the mini games are fun. All right, so we have these three numbers as the answers to those three questions that I posed like 25, 30 minutes ago now. I apologize. Do we have any questions? Is this what you guys got?
I got 31.8, but that's because I rounded.
To one digit instead of two, yeah. Okay, all right.
The second one, I only went halfway through it and I got stuck. And the third one, I didn't get that at all.
Okay, all right. Does anybody need to see number one at all? Anybody online?
Please, yes.
All right, let's
Number
just do them
one.
all. All right.
Okay, please. I don't know what do I have different. Okay.
All right, let's do this. So we want the percentage when of 30, that 34 is of 107.
Yep.
Okay, so if we set it up like the other problems we were doing, we know that the percentage times whatever our original amount, whatever our whole amount is, ends up equaling out to our partial amount. So if I set it up this way, and I don't know what the percentage is, we could call it, say, P for percentage. I like to go that route. Multiply it by the original, that whole number, because we need to know what 34 is out of that 107. So it's going to equal 34. And then you would divide off that number. And the shortcut to doing this is knowing that you can divide these two numbers to get the percentage every time. That will work. Oh, and for Alexis's question, and I guess everybody else's question, in terms of making like a syllabus, we're not quite at the level of being able to have a formal one. I can put something together as kind of like an outline to my class on the shared folder for their Google Drive. My goal for this particular class is to make it halfway through that particular goal set. And then we were talking about doing some short videos and potentially doing some credit for those. What I was thinking is that if there's any subjects you guys need to see from the other half of that, I could make short videos on it and we could work from there. That's entirely up to whether or not you guys would make use of that at all. Okay, so if I divide these, I get this, and we want to round to the nearest two digits like the problem says, but you want to make sure that we convert it to a percentage first. So right now we have the decimal form of the percentage. So we move it over. And we say, hey, we're trying to round to this digit. So you look at this digit and then look at the digit afterwards. And you say, since that one afterwards is a 5, that means this is going to round up. So we'll be at 31.78%. Makey sensey?
Yeah.
Now the second one, we have 67 is 14% of what? Notice I put the equal sign there when I saw the word is, because that's where it'll translate pretty directly. When you ever see the word is, usually that's an equal sign. So we have 67 is 14% of something. Let's figure out what it is. So I'm going to keep this structure. Convert that to a decimal, and we don't know what the whole number is. I'm gonna put a W, just because, whatever. And then since this is multiplied onto that, we're going to undo it by dividing. And our whole number, our original amount here would be 67 divided by that 0.14. I get 478.5714, blah, 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 but that's the digit we care about. Look at the next digit over, it's a 1, which means we would round down, so 478.57. I guess technically I wouldn't circle that W equals, because this wasn't an algebra problem in the first place. Just wants to know what the number is. Like I said before, if somebody asks you how far something away is and you tell them D equals 4 miles, they're going to be very confused. I didn't say anything about the letter D. Does that make sense to everybody, or do we need any clarification? Now you might notice that I have this set up almost the other direction that I set up all the other ones. But as long as the same things are equal on both sides, then it doesn't matter what's on, like where the equal sign is, as long as it's equaling the correct thing, right? I don't know if the word salad that just came out of my mouth made sense or not, but you know. And then the next one was, what is 3% of 14? % of 14. Well, remember, if you're converting this to a decimal, you look where the decimal is now and you move over twice. But your problem here is there's nothing here, right? Well, if there's nothing there, then you put a 0 because what's there? Nothing, 0. So that would be 0.03. And we're finding that of 14, so we multiply that by 14. And we don't need to put a variable, we don't need to set it up like all the others, because again, all we need to know is that 3% of that 14. In this case, Mr. Calculator spits out 0.42, which is already 2 digits, so we don't have to worry about rounding. We don't need to worry about converting anything because this is a partial of this number. This is not a percentage. Always be careful of that. A lot of times I'll see somebody do a problem like this and I'll just randomly slap a percentage symbol on something. Just be careful of what it is you're solving and what it is you're solving with the part.
I was about to.
Yep, that's really common. Somebody would look at this and might switch it over and call it 42%. You just got to remember what it is you're looking for, what it's solving for. It's very, very important to make sure that you're keeping everything straight. That's actually a lot of times why I will write this way. I'll write out, hey, I got like the basic in English, then I got a little bit more mathy happening here, then I go full mathy. You know, just kind of build it up to it. As long as you do that, it tends to rule out some potential missteps. which I'm very good at making those missteps. I will always remember accidentally pulling out an 8 instead of a 1/8 and accidentally having 64 times an answer. And that is the only thing that kept me from getting 100% on a calculus test. I never got 100% on any test. That was the closest I got. Just that freaking 1/8. Gotta watch what you're doing. All right. Hey, look, more stuff on percentages.
Yeah.
Oh my God, we're so behind schedule.
I wonder why.
Well, whatever. All right, let's do this. I'm blaming you.
Okay, fine, I'm leaving.
I don't think anybody's freaking out about that. I don't know. Is anybody excited to do percentages?
Everybody is.
Oh, yes, we do.
Yeah, we're excited. Oh.
Yeah, it was a trick question. You all were, so
There you go.
yeah. So percent increase and decrease. Not really a whole lot different compared to what we were just doing. It's really just figuring out, hey, what percentage, like if you're at a job and you got like a 15% raise. You're like, that's great. What did I just get a raise of? What is that? Figure out what 15% of what you made is and add it to it, right?
I remember they did that to me and it was like a year, every year, it was like 15, depending what. One year it was 15% and next year it was like 20.
Yeah, right. It's always something small.
Yeah.
They used to call it,
Right, when they said it, this meant.
they used to call it cost of living increases.
Oh,
and-
and there too. Oh,
Yeah.
Maybe I'm like, it's way more than that.
Yup. And you know what? Inflation year over year is really high, and you know what? Nobody's getting raises and everybody's got record profits.
That's what we need to describe.
Yeah. Record profits. All right. So, for example, this problem right here, which is way too close to something that I personally dealt with. Say you were once making $12.28 per hour and you now are making $13.75 per hour. How would you figure out the percentage of the raise you just got? Well, first of all, you're gonna, how much more are you making? Well, you subtract one from the other to figure out the difference. So $13.75 minus $12.28 we get is $1.47, right? Okay, so you then need to know, hey, that $1.47, what percentages of that of the original amount? It's always important to make sure that you're finding it out of the right amount, because some people might do it out of the new amount. And that's not going to tell you the percentage increase that you made. That's going to be out of what you make already. That's not really telling you a whole lot. So you go out of the original amount you made. So 147 divided by 1228, kind of like what we just did on the last couple of problems, and we get a decimal form of a percentage. So the partial amount divided by that whole amount is the decimal percentage. Pretty close to 12, so round it to 12%. And there we go. So yeah, not too bad, yeah. You're just figuring out what that difference is. And then you're figuring out what the difference is of the original amount. So it works exactly the same with percentage decrease. So let's say we found a ridiculous amount of oil that caused our crude oil prices to plummet, leading to a decrease in the cost of gasoline. Your usual spot has gone from 3.499 per gallon. And as I have here, ever notice that 9/10 at the end of the price? Yeah, $3.49 and 9/10 cent price to $2. I don't even know how to say that out loud. $2.149. I guess it would be. Per gallon, what would be the percentage decrease? I thought about not having the nines there and that would bother me too much. So you figure out what the percentage decrease is going from the 349 and change to 214 and change. So you figure out what the difference is, so you subtract them. Larger amount minus the smaller amount. So you know, okay, it went down by $1.35. You're going to divide it by the original amount, which was the 349, and you get a decimal point. That is the decimal form of your percentage of the change. Now, along the same vein, we also have discounts. Same sort of idea, right? Something's going out, going down. That's a percent decrease. So, practical application, you're in a store, you're grabbing something that's $14.99, but it's 15% off. So what is it? So you can find 15% of that $14.99 by multiplication. We figure out, okay, 225 is that 15%. Take it off the original amount, and that's what the price is now. Do we like it? Do we not like it? We love it. Okay. Oh, now you whisper. You don't need to whisper.
Bye.
Goodbye.
Bye, guys.
Have a wonderful evening.
You too. Bye, online people. Nice to meet you.
Nice to meet you. Take care.
You too.
Oh man, I like that I lost half the class on the line in the last, half hour of talking. Brutal, huh? Yeah, that's filling out. Cool. All right, let's do some problems. I like problems. You like problems? There's one thing I'm good at, it's having problems. All right. So if the temperature outside goes from 57 degrees in the afternoon to 17 degrees at night, and I think I wrote that on the day that happened and it made me angry. What is the percentage decrease? Well, that's the amount, but we need the percentage.
40%.
No. Okay, so what we're looking for is how much percent of the original amount dropped. So 57 minus 17, we know that there was a change of 40 degrees, right? So that's the amount that it's changed. We need to know what percentage this is of our original. And like we covered already, all you gotta do is take that change amount and divide it by the original. Whatever Mr. Calculator spits out is gonna be our answer. Well, the decimal form of our answer, I should say.
I was never gonna get that.
No, probably not. Well, I mean, you kind of could have. So if I was to write this out, I don't really know how many digits I want, whatever, let's write that. And then we move it over twice to get that percentage. It would be 70.175%. That is how much it dropped. Yeah, sometimes I ride my bike to work. And by sometimes, I mean, whenever the weather isn't snow. And when I have to be there by 6 in the morning and it's Nevada, it's freaking cold. I cannot feel my hands by the time I get there because I live down the hill right here and I work there. It is roughly 6 miles.
Not anywhere close to it.
Yeah. Yeah.
One hill to the next.
Yeah, so 6 miles on a bike in 17-degree weather, I literally cannot feel my hands when I get there, which is awkward because then I have to put a needle through people's arms.
I had to make tile cuts outside of the house today, outside of the weather, and that, my hand freezing,
Yeah,
and it wasn't too bad.
I do not appreciate this return to winter that we had today.
No, not at all.
My girlfriend got an inch of snow at her place and it's still snowing. All right, number 2. I also used used actual experience from this. You find yourself with a 20% off coupon for a Turbo Man figure. The very same from the 1996 Christmas classic movie, Jingle All the Way. Which is a great and terrible movie with Arnold Schwarzenegger and Sinbad. The store has its price listed at $29.99. What is its current price? There's 2 movies I like to watch every year at Christmas. One of them is Jingle All the Way. The other one is Die Hard.
Oh, no, sure. I'm always trying to feed my inner child. Remember the movies with, like, it's the kid ones, the,
claymation ones.
yes.
Yeah.
Yeah, I like those, and I wore them to death with it every Christmas and stuff like that.
You know, as long as it's not not the movie A Christmas Story, because I hate that movie. I do. I hate it. Like this movie sucks. I don't get why this is the thing. You're like, we play it every year, 24-hour loop. No,
That's my mom's favorite Christmas movie.
it's terrible.
I've never really paid attention.
Apparently, I think last year or the year before, they actually brought the same guy who played the kid actually came back and did a sequel.
Probably shit too.
Oh, I'm sure. Okay. So it was $29.99. We are taking 20% off. What is the current price? Well, I need to know what 20% of that is. So $29.99, and we're gonna multiply it by the decimal form of this percentage, which would be 0.20, right? Gonna multiply that across. Now, believe it or not, you could probably do this one in your head. Because if I had to round that to the nearest penny, that would go up. So that would go up, so that would go up, so that would go up.
So 6.
6, yeah. Because, hey, what's 10% of $29.99? Well, $29.99 is $30. 10% of 30 is 3. What's 20%? Twice that. 6. Okay, so what's the current price? $29.99 minus 6. So we have $23.99. Ta-da. Not bad, yeah. Not bad at all. Okay. Now, number 3 relates directly to that. Relating to number 3, what is the total after a 7.6% sales tax? Which at the time of writing was the sales tax rate for Carson City County, which is awful to say, but it's how this works. I believe it's now a variable tax rate. I don't quite understand how the heck that works. Went through Jack in the Box and we had like 8-point-something% sales tax, and I'm like, it's 0.5% less over there.
Yeah.
Not gonna throw a tantrum for that quarter, but still.
Just go inside and have a restaurant.
Oh yeah, fast food's nuts. Forget where, yeah, McDonald's. And we went to McDonald's the other night. Me, my brother, my parents, nobody got drinks, just sandwiches, fries, left, $55. Ugh.
I took them all yesterday, go, Sunday, yesterday, each wanted one for the local, the other one McDonald's, one in and out. That was not cheap.
No. Whereas, uh, I miss dollar menus.
Me too.
Used to get a McDouble, McChicken, throw the chicken in the middle of the McDouble.
Throw the fries in there while you're at it.
Yeah. I don't know why, it was like one of the tastiest things I've ever had in my life. But now doing that's like $7.
Yeah.
All right, 7.6% sales tax on that. What is going to be our total? Well, we need to know what 7.6% of that is. So we convert this to a decimal. 0.076. And we multiply it by the 23.99. And since this is dollar amounts, we are going to be rounding to the second digit. So it'd be $1.82. So that's the sales tax. So we take that and add it to the original amount. So we get $25.81. Now, there is another way to actually find that. If all you care about is the final total, you don't care about the exact sales tax amount, you could look at this and say, oh, well, if I need to know if I'm adding 7.6% of this to itself, well, what percentage is this of itself? It's 100% of itself, right?
Yeah.
Well, 100 plus 7.6 would be 107.6%. So if you wanted to find 107.6%, you'd move the decimal over 1.076, multiply it by that 23.99. And we get the same answer. So the whole idea here was, here we are just finding the 7.6% of it and then adding it to the original amount. So we could very easily just split that apart, say, okay, this is the subtotal, this is the tax, this is the grand total. Here you would just be, that's what it is after tax, just straight away. When I was working retail and I had to figure out what the final price on something was, I would just grab our calculator and multiply it by 1.076 every time. It would work. Cool. Do we like playing around with percentages?
That's more for us.
Well, specifically for you. I'm going to give you guys a minute to do that last problem right there. And then we'll review it. If you order 20 chicken nuggets and you get one extra, the most special of nuggets, what is the percentage increase? I ordered 2 4-piece once at Burger King. I got 2 5-piece. I was like, that man deserves a raise. I'm never gonna tell his boss, but that man deserves a raise. Huh?
Valid.
Good. And for time, you all have the amount of time it takes me to finish eating a slice of pizza.
There's another slice that you.
Right, I'm done. What do we get?
5%.
You are correct, sir.
He is correct. He's still trying to like walk me through it.
Okay, all right.
You are too.
I respect it. I respect it. Yeah, percentages aren't everybody's favorite thing, so. Okay. So the question is, we have 20 nugs. You give one extra nug.
Yeah.
What's the percentage increase? So we need, we don't really need to worry too much about what we end up with, because we ended up with 21 nuggets, but we don't really care what that is. Because every single one of these problems has us finding the difference between what we had and what we ended up with, which in this case, we know it's one, right? We have one extra. And we're looking to figure out, hey, what's the percentage this is of our original? Well, every time you have to find the percentage of the original, you're going to take the amount change and you're going to divide it off the original amount. So it's just 1 divided by 20. Now, in this case, you could just throw that at a calculator, get 0.05, and you move that decimal over, we get 5%. It's a sacred nugget. Get an extra. I saw somebody post online once that they, you know, when they worked at fast food, every single time they did nuggets, they always added an extra. King among men. I'm still mad about buying nuggets at freaking KFC. That was a terrible idea.
Oh, I went there today, but normally I just get the penny.
I'm a sucker for their spicy chicken sandwiches.
Oh, that's yeah.
They got small the last couple of times I went there. But my God, they were huge for a while.
I like to get the one. I don't know if it's no. I think it is Burger King. Their chicken sandwich is pretty fat.
Yeah. I haven't been really big on Burger King for a while. I used to go to Burger King. I used to live across from Burger King in that apartment complex.
Right.
Yeah, so I'd go in there so often that The entire staff referred to me as 20-piece. I was walking down the road one time, somebody slowed down, yelled out his window, "Hey, 20-piece!" I was walking with somebody and like, what was that? I'm like, that's my rap name. That's my rap name.
Just come for the cool.
20-piece.
20 pieces coming with soda.
They were so upset one lunch rush when they had my order ready for me by the time I got to the front and I ordered something else. So upset. All right. Do we have any questions on percentages before we move on? I would like to regain an hour, but there's at least an hour of this class that was wasted, right?
Oh,
Oh, yeah. Oh, yeah. All right.
It's all right.
Mm.
We'll get to it.
Will we though?
We'll take some more pizza.
All right, so let's do some new fun stuff.
Exponents.
Exponents. We love exponents.
no.
Yeah, you do. You do.
Oh.
No, you do. You love it.
Right, someone loved it.
Yeah, there you go. All right. So exponents are shorthand for repeated multiplication of the same thing by itself. So shorthand for multiplying 3 copies of the number 5, shown on the right hand of that equal sign. 5 times 5 times 5 is 5 with the little 3 up top. So the process of using exponents is called raising to a power. So the exponent's power. So 5 to the third can be pronounced 5 to the third, or 5 to the third power, or even 5 cubed, because there's a couple of special ones. Huh? So like I just said, there's 2 specially named powers. Second power is generally pronounced squared, and the third power is generally cubed. So 5 to the third there is commonly pronounced 5 cubed. So in mathematics, the caret symbol, which is that little upward facing arrow thingy on every keyboard you'd ever use, is used to represent an exponent, such as an exponential power like square or cube. So you might see 5 to the third written as 5 with a little caret and then a 3. Just showing you 5 is going up to 3. Some calculators have the exponent button as a caret or XY. I don't know why the XY, it's never like X to a power of Y. It just says XY and it makes me angry and it doesn't make any sense. But for a visual, this is like Mr. Standard test calculator here. And there's the power button. So if I wanted to know what 5 to the third power is, 125, because 5 times 5 times 5. 5 times 5 is 25, 25 times another 5. You got 5 quarters, you have $1.25.
The calculator has the third power, it's just the same thing.
So yeah, my calculator, for instance, even has a square button. If I do 5, just hit that. Just brings it up to a square. If you just have a 3, then that's a cube button. You probably have it on there. Every calculator is different. It's annoying. Are you doing a phone one?
Yeah, and they open it up a lot.
Yeah, phone ones are awkward.
Yeah,
When you hold it portrait, it'll be basic, and then you hold it landscape, and it's
yeah, I didn't know that until right now.
yeah.
Oh, shoot.
Or if you're really crazy, you could be like me and go on at least on Android, there's a program called what is this? Calc 84, and it does its best to be something close to like a TI 84
Oh.
calculator.
Oh,
That's on your phone.
Yeah. It's trying its best to be something kind of like that. But see, even on big, stupid, expensive calculator, I still just have a caret button. That's apparently 5 to the 7th. Big, stupid, expensive calculator, though, will let me go crazy on digits, so. But I bought this so that we don't have to stress it. Okay. Question.
Yeah, an eraser.
Do I have an eraser? Actually, no. No, I do not.
I do.
Just spit on it, wipe it off. That'll be fine. I have an eraser for pen. This would go straight through the paper. So, how do you break something down into an exponential form? How do you break something down into an exponent? Using 125 as the example, if you find the factorization using something like, factor trees again, you break down to a factor tree and you see that you have nothing but 5s, 5 and 5 and 5. You look at that and say, oh, okay, I got 5. How many times? 3. You do the 5, put the 3 as the exponent, call it good. Why do I not actually have?
And it doesn't.
There we go.
This turns into an exponent, it doesn't always, is it always gonna require that exponent sign or just?
If you're putting something into an exponential form, yeah. So here we got some fun examples.
Exponents, one examples.
Fun example, the most fun you've ever had in your life. Myself enough room to actually do this. I feel like I'm missing something. Okay. It's one concept that I didn't put on the notes, but we are going to cover it anyway because honestly, it's not bad. And it's just going to be in these last couple. So if I am going to take this stuff and I'm going to convert these ones into an exponential form and these ones out of an exponential form, the ones going into it, you just factor tree as far as you need to. So we have 3 times 3 times 3 is 27. So that means you have a 3, and then you say how many times you have it? Well, 3. You put that as the exponent and you call it good. 3 cubed. Same with 4. 4 is 2 times 2. So we have a 2 as our factor, and you write how many times you have it. Twice, 2 squared. Yes, I did 3 cubed and 2 squared on purpose as the first 2 problems for no good reason. All right, number 3, we have 343. Written terribly. All right, 343. I don't know what that is, so you start throwing numbers at it, because we're doing the factor tree, so divided by, oops, divided by maybe a 3. Nope, I get a weird decimal. Let's see. So it's not even, so no even numbers will go into it. 3 won't, 5 definitely won't, because it doesn't end in a 5 or a 0. Try a 7. 7 and 49. And 49 is 7 times 7. So we have a 7 3 times. 7 cubed. Now the next couple are a little more tricky. 72 is 2 times 36. 218, 2 and 9, 3 and 3. Almost gave myself a number. Okay, so we got a bunch of 2s and 3s. How do I write that? Same sort of way you did before. We would write what our factor is and say how many times we have it. 1, 2, 3. And see, all of these things are multiplying together to get that 72. So if I'm breaking this down into exponential forms, then whatever else I need on here is also going to be multiplied. Now, I don't need the multiplication symbol between these, because if you have these next to each other, it's implied that they're being multiplied. So we have this 3 twice, so we have 2 cubed, 3 squared. And that's it. And then we have 900. First thing I would do, 9 and 100. 9 is 3 times 3. 100 is 10 times 10, which is 2 times 5. And 2 times 5. All right, so to keep things straight, I usually would start with the smallest of our factors and work my way up. In this case, our smallest one is 2. We have 2 of it. In fact, we have 2 of everything, right? 2 2s, 2 3s, and 2 5s. That's exactly how we're going to write it. 2 2s, 2 3s, 2 5s. That's it. Not bad, yeah? Not bad at all. Okay. Now, the other way is significantly easier, because 7 squared, you just multiply 7 times 7.
49.
Cool. That's it. 4 cubed is 4 times 4 times 4. 4 times 4 is 16. 16 times another 4 ends up being 64. So these ones you are literally just multiplying out if you don't have the proper calculator, or if you do, you just punch it in exactly as shown. Like this next one, 2 to the 4th. It's 2 times 2 times 2 times 2. You could break that down. If you have a calculator that'll do it, you can just do 2 to the 4th, 16. Otherwise, one strategy I like to do if I don't have a good calculator handy is I might write them out and then say, okay, these ones give me a 4, these ones give me a 4, and I can do it that way. That might work for you, that might not, it's up to you. All right, and number 9, we have 4 cubed, 2 to the 4th. So 4 cubed 2 to the 4th, like I said over here, that implies that these are multiplied together, right? We just have to figure out what they are. Now, I did this on purpose. They're the last two problems. 4 to the third, we know is 64. 2 to the fourth, we know is 16. So you're gonna multiply those guys together. So you get 1,024. Now you could potentially, depending on the calculator, write it out exactly that way. Let me see if this one will do it. Yep. You could potentially write it out this way. Particularly, I just noticed on this calculator, when I do 4 to the third power, if I keep typing, it's going to stay in that exponent. So at least on this calculator, I have to actually arrow over, so I'm no longer in that exponent. Here, if you want to be careful, you can hit multiplication. Your calculator might need that. It might not. This one doesn't, but you could just do that. Do 2 to the fourth there. Get that 1,024 again. Or you could do it piece by piece, find each individual one and multiply them together. How you do it is entirely up to you. Does not matter. Okay. So what do we think about this? Not bad, not bad at all, right? Nor should it be, because this is essentially, I always like to say that math is a bunch of building blocks you build on each other, like you get to calculus and it's literally just, hey, all that stuff you learned up till now, put it all together and work with it. That's really it. I always tell people going into calculus, it's like 2 new steps of calculus, and the rest is just algebra all the way down. I was not as good at calculus when I was taking it as after I started tutoring algebra. That actually made life so much easier. Okay. Based on the amount of time we have, I'm going to skip the alone problems. I'm sorry, I know you were all looking forward to doing a few of these.
Darn it.
There were only just a couple, but yeah, we're skipping them. Let's move on.
I didn't completely understand the last slide.
Huh?
Wait, I didn't completely understand the last slide. Just kidding.
I mean, I could. All right, so multiplying them together is where we're at. Now, it's all well and good if we have them like the last problem where we would have different base numbers and different exponents being multiplied together. You just expand them out and multiply those numbers together, right? But there's a nicer way to do it if the base numbers are the same. If we have 3 to the third multiplied by 3 to the fourth, you can just add the powers together. Because, hey, I have 3 of them multiplying together, and I'm going to multiply that by another 4 that are already being multiplied together. How many do I have that are now all multiplied together? So you just add the powers that way, and it works out every time. Now, like I have there at the bottom, if they did not have the same base, the only thing you could really do is what we did on the last group of problems, figure them both out separately and multiply them together. Now, this is a lot nicer to do than what you would have to do normally, because 3 cubed is 27, 3 to the fourth is 81. So this is 27 times 81, 2,187. I would rather not deal with that. If I can look at this problem and say, oh, yeah, if I put those together, it's just 3 to the seventh. All right, good enough. That'll work. You know, depending on what you're doing, you might still have to expand out that 3 to the seventh, but that's just hitting your calculator a couple of times, you know. It's a lot easier to do the work of adding 3 and 4 than 27 times 81. And that's that concept. Let me work out these problems. And again, I'm gonna skip the alone ones because I just want to cover as much as I can right now. So we are covering some bases. Use the same page.
You ride up that hill. On your bike.
What, this one, that one? Yeah.
Oh,
There's another hill.
Yeah, this one. That's my bike out front. I have an electric bike.
okay.
Now, that seems like it makes a big difference until you realize that I got a very cheap electric bike. And if I just use the throttle the whole way to work, either way, it would die.
So you pedal once.
I have to pedal, yeah. I have to do the pedal assist thing.
Oh, my.
It helps the uphill.
You go home, you just,
Oh,
you still.
home is easy. I don't have to pedal at all. Although I will say, I did have a bike once that, my dad was working at Walmart and he got me a new bike. And Walmart bikes aren't the best. But the guy who was building the bikes was some crazy old man who apparently preferred to be referred to as cowboy. Because he always wore a cowboy hat. And that concerned me enough. But my dad made sure that he had a bike that cowboy built, because he trusted his friend. As I was going down this hill from the college here, down College Parkway, my handlebars came loose. Oh, so they were rattling all around. I was like, oh God, I'm gonna die. I'm gonna die. Pulled it off. Stopped, walked, did not have a proper set of tools with me. But I was like, all right, you tell cowboy. I never want to see his face. Like that was not cool. Oh,
Talk about going to the rodeo, but he brought the rodeo to you.
yeah, that was not cool. Okay, so all of these, we're gonna leave in exponential form. First one's real nice. We have 2 to the 3rd times 2 to the 6th. All we're gonna do, we leave the bases the same and we add the powers. 3 and 6 is 9. That's it. Yeah, so 2 cubed times 2 to the 6th, 2 to the 9th. What is 2 cubed? What is 2 to the 6th? I don't care. What's 2 to the 9th? I also don't care. This is a number, equals that into number. All right, we're happy with that.
The next one, I'm taking a wild guess. Would that be 5 to 7?
Not quite. Now, what I'm gonna do is I'm gonna first convert everything into exponential form.
Oh, yeah, you did say.
Because 25, I want all of these in exponential form as the answer, but 25, how many 5s does that multiply together? 2, right?
Yeah.
Yeah, it's 5 times 5. Okay, so if I got 5 squared times 5 squared, all I gotta do is add the powers. 5 to the 4th. And then down here, well, I'm gonna leave everything in exponential. But these, we have a base of 3, a base of 2, and a base of 3, right? And the 3 doesn't even have any exponents. So what do? Well, first of all, we can't mix these together because they don't have the same base, right? The only things we can put together are the ones that have the same base number, which in this case is a 3. Okay? Now, since they both, these guys can actually go together, how am I going to add them? Because this one doesn't have an exponent. But it will combine with this 3 cubed because all of these are multiplied together. This just means how many do I have multiplied together? I have 3 of them multiplied together, right? So if I added one more that I'm multiplying on here, you're just gonna add that one. We end up with 3 to the 4th from it. Now, the 2 squared doesn't really help anything. That's just gonna hang out. But whenever you have a number just kind of hanging out and you're trying to combine it with an exponent, you can always remember to say, hey, how many of that number do I have right here? 1. And think of it as combining that one. So 3 to the 4th, 2 squared is as clean as I can make that as an exponential. Now, on number 4, I wrote this one this way purely so you could see the carets as a problem. But you would interpret this with the exponents like that. Now, if I'm multiplying these guys together, I leave the same base and add the powers, right? Power of 2, power of 5, 2 and 5 gives us 7, so we have 7 to the 7th. All right, how do we feel about this?
Good.
Not bad, yeah? Okay. All right, so
Excuse me, in this case, we don't use multiplication, just
just the
Add.
addition, yeah. Yeah, because we're just adding the powers, because what's happening is we do have multiplication happening. But what's happening is this is already a bunch of stuff multiplied together, and that's multiplying by a bunch of stuff multiplying together. So what we can do is say, well, how many are being multiplied together? And that ends up just being addition because there's 2 of them here and there's 5 of them here. And if I multiply them together, I have a total of 7 of them.
mhm.
So it's kind of funky with multiplying exponents, you just add the powers.
Okay.
Yeah, see that a little better?
Yep.
So I don't think we have time for any more topics. I'm glad we got as far as we did. I'm very glad we got as far as we did.
Right.
So yeah, since there's, grand total of 5 left and what used to be like a dozen, this is a good time to stop. You guys are free to go. Anybody wants the last slice of pizza there?
It does.
But otherwise, yeah, if you guys need anything at all, let me know, shoot me an email. Otherwise, I will see you Thursday evening.
Okay.
Have a good night, everybody.
Yeah, you got the box number? You got the box? Yeah.